Welcome, dear friend, to Luminous Uplift, a quiet corner of the universe where science and serenity meet, and where every story is carried to you on the softest breath of starlight. We are so glad you are here tonight. Perhaps your day has been long, filled with noise and motion and the endless turning of earthly things. Perhaps your shoulders still carry a little of that weight. Let it go now gently, the way a leaf releases itself to a slow autumn river. You are safe here. You are still, and the night sky is waiting to welcome you home. Here at Luminous Uplift, we believe that the universe itself is a lullaby, vast and luminous and endlessly kind. We gather these stories not to overwhelm, but to uplift, to remind you that wonder and peace can exist in the very same breath. Each journey we take together is an invitation to rest your mind while letting your imagination float freely among the stars. Tonight, we drift together through the breathtaking family of worlds that circles our beloved sun. From the sun-warmed dust of rocky inner shores to the cold and elegant rings spinning in the outer dark, our solar system is a gallery of quiet miracles. Each planet a chapter in a story, billions of years in the making. If these gentle voyages bring you peace, we warmly invite you to like this video and subscribe, so we may continue meeting here together beneath the same infinite sky. Now, let's begin our journey through the planets of our solar system. Close your eyes for a moment and let yourself drift back, not to yesterday, not to last year, not even to the earliest pages of recorded human history. Let yourself drift much further than that, further than the first cities, further than the first fires lit by human hands, further than the oldest bones we have ever uncovered from the earth. Let yourself drift back beyond all of that, past the forests and the oceans and the cooling of the ground beneath your feet, past the very formation of this beautiful blue world we call home, past even the earliest whispers of the planets themselves. Let yourself drift all the way back to a time so ancient, so vast, so incomprehensibly long ago, that the numbers themselves seem to dissolve into something more like poetry than mathematics. We are going back now 4.5 billion years, 4.6 billion years to be more precise. And if that number feels too large to hold in your mind, that is perfectly all right. Simply let it wash over you like a wave. Like the feeling of standing at the edge of the ocean at night and looking out at the dark water stretching away toward a horizon you cannot quite see. Some things are not meant to be grasped. They are meant to be felt. Imagine, if you can, that you are hovering somewhere in space, not the space we think of today, with its familiar constellations and its carefully mapped planets and its orbiting machines built by human hands. This is an older space, a quieter space, a space that has not yet decided what it wants to become. All around you, in every direction, there is darkness. But it is not an empty darkness. It is a full darkness, a rich darkness, the kind of darkness that holds things inside it the way a seed pod holds what will one day become a tree. And what this darkness holds, scattered across distances so enormous that light itself would need millions of years to cross them, is a cloud. A giant molecular cloud, the scientists call it. A vast, slow-drifting accumulation of gas and dust, of hydrogen and helium, and traces of heavier elements forged long ago in the hearts of stars that lived and died before our sun was even imagined by the universe. This cloud is not dramatic. It does not glow or roar or crackle. It simply exists, patient and enormous, swirling so slowly that a single gentle rotation might take hundreds of millions of years. It is ancient in the way that mountains wish they could be ancient. It has been here, in one form or another, since long before the story we are telling tonight began. And then, something happens. Something always happens eventually in the universe. Perhaps a nearby star ends its life in a tremendous explosion. A supernova sending rippling waves of pressure outward in all directions, like the rings that spread across still water when a single drop falls in. Perhaps the cloud simply grows dense enough in one region, one particular pocket of gas and dust, that gravity begins to do what gravity has always done so quietly and so persistently since the very beginning of everything. It begins to pull things together. And once gravity begins, it does not stop. It is patient in a way that nothing else in the universe quite manages to be. Slowly, over thousands and then hundreds of thousands of years, that particular region of the cloud begins to collapse inward. The gas and dust begin to fall toward a common center, spiraling as they fall the way water spirals as it drains, the way leaves spiral as they fall from autumn trees on a still morning. The cloud begins to flatten itself into a disk, a great slow wheel of matter turning in the dark, and at the very center of that disk, something extraordinary is gathering. At the center, the gas is falling fastest and gathering most densely. The pressure builds and builds, and with pressure comes heat. Not the gentle warmth of a hearth fire, not even the fierce heat of a lightning bolt. This is heat on a scale that has no real equivalent in any human experience. The temperature at the center of this collapsing core climbs into the millions of degrees, and then it climbs further still, until it reaches something the human mind can barely approach without a kind of awe that borders on vertigo. At the very heart of what is forming, temperatures eventually reach approximately 15 million degrees Celsius. 15 million. At those temperatures, the hydrogen atoms that make up most of this swirling mass can no longer simply exist as atoms. They are stripped of their electrons, reduced to bare nuclei, protons hurtling through an environment so extreme that they begin to collide with a force great enough to fuse them together. Hydrogen nuclei merge to form helium, and in that merging, in that alchemical marriage of the smallest things, an almost unimaginable amount of energy is released. Light, heat, a pressure that pushes outward against the inward pull of gravity, and in the balance between those two forces, in that perfect and precarious equilibrium, a star is born. Our star, the sun. It is difficult to overstate how central the sun is to everything that follows in this story. In terms of sheer mass, the sun does not merely dominate the solar system. It essentially is the solar system. Everything else, every planet and moon and comet and drifting asteroid, all of it combined, amounts to barely a fraction of what the sun contains. To be precise about it, our sun holds within its enormous body approximately 99.86% of all the mass in the entire solar system. All the planets, including the great gas giants Jupiter and Saturn, with their crushing gravities and their swirling storms. All of that together makes up less than 1/4% of the total. The sun is not the center of the solar system in merely a symbolic or convenient sense. It is the center the way a continent is the center of an ocean. Everything else is, in some beautiful and humbling way, a kind of afterthought. A lovely, intricate, meaningful afterthought, but an afterthought nonetheless. Picture the newborn sun, then, blazing to life at the heart of that slowly spinning disk of gas and dust. It has not yet become the steady, golden, reliable star we know. It is younger, more energetic, more volatile. It blazes and flares and sends tremendous streams of charged particles rushing outward in all directions. These streams, these solar winds as we call them, pour out from the sun at extraordinary speeds. Even today, in the sun's calm middle age, solar winds travel outward at somewhere between 400 and 800 kilometers per second. 400 kilometers per second. In the time it takes you to draw a single slow, relaxing breath, the solar wind has already traveled thousands of kilometers from its source. In its youth, the sun's winds were stronger still, and they played a crucial role in shaping what the solar system would become, sweeping and pushing and sculpting the material in that protoplanetary disk, clearing some regions and compressing others, helping to determine where and how the future worlds would form. And now we come to perhaps the most quietly miraculous part of the story. The disk that surrounds the newborn sun is not static. It is alive with motion, with collision, with slow accumulation. The particles of dust and ice and rock that swirl through it are constantly bumping into one another. And sometimes when the collision is gentle enough and the surface is sticky enough, they do not bounce apart again. They cling, they join. Over time, tiny grains become small pebbles. Small pebbles become larger pebbles. Larger pebbles become boulders. Boulders become something the scientists call planetesimals, bodies perhaps kilometers across, and then tens of kilometers, and then hundreds. This process is not fast, not by any human measure of time. It unfolds over tens of millions of years. This patient, persistent building up of worlds from almost nothing, this extraordinary transformation of scattered dust into solid spinning spheres. Tens of millions of years of collision and accumulation, of gravity drawing more material to each growing body, making it more massive, making its gravitational pull stronger, helping it draw in even more material in a slow cascade of construction that has no parallel in any human act of building. Imagine lying somewhere in the dark tonight and trying to feel the passage of 10 million years, then 20, then 30, 40, 50 million years of slow and patient world building, all of it happening in silence, in the dark spaces between the growing body of the sun and the cold outer reaches of the disk. Time so vast, it becomes almost like a texture, like the feeling of very old stone under your fingertips, something you can sense but not fully comprehend. And yet, from within that almost incomprehensible span of time, something precise and orderly emerges. A system, a family of worlds, each one occupying its own territory, each one shaped by the particular conditions of its distance from the central fire. Each one carrying within its rock and metal and atmosphere the memory of the cloud from which everything began. The inner regions of the disk, closest to the sun, are too warm for ice and certain lighter compounds to survive in solid form. The solar winds and the radiation of the young star strip away the lighter gases, leaving behind only the denser, rockier materials. It is here, in these warmer inner precincts of the forming solar system, that the rocky terrestrial worlds will take shape, and among them closest of all to the newborn sun, one small, dense, battered world will find its place in the tightest of all orbits, so close to the source of all that light and heat that its surface will eventually be shaped by extremes no other world in our solar system quite matches. But that world's story, like all the other stories waiting inside this long night of gentle exploration, belongs to what comes next. For now, let yourself simply rest in the image of that early solar system, vast and ancient and slowly coming into being, the sun blazing at its heart, the disk of gas and dust swirling patiently around it, time moving in great slow waves that dwarf anything our brief and precious human lives can easily contain. Let yourself feel the scale of it, not as something overwhelming, but as something comforting. There is something deeply peaceful in knowing that all of this, every grain of dust on every windowsill, every atom in your body, every breath you take, has been part of a story so much longer and larger than anything we can fully see. We are made of this ancient cloud. We carry inside us the memory of those first collisions, those first slow gatherings of matter in the dark. When you close your eyes and breathe slowly in the quiet of the night, you are in some small and beautiful way, the universe resting from the work of 4.5 billion years. And the disk is still turning out there in the long, slow dream of the past. The dust is still falling together. The sun is still blazing at the center of its new and growing family. And from that slow, swirling cloud of ancient dust and fading starlight, the first rocky worlds began to take shape, drawing together grain by grain, pebble by pebble, as the innermost planet of all quietly gathered itself from the warmth closest to the newborn sun, a place so near the fire that nothing could easily survive without being remade entirely by the sheer, unrelenting force of that proximity. Mercury gathered itself slowly, the way all quiet things do, not with grandeur or spectacle, but with patience, with the unhurried accumulation of small moments stretched across deep time. Grains of iron and silicate drifting together in the warm haze closest to the young sun, bound by nothing more dramatic than gravity's soft insistence. Until one day there was something where before there had been almost nothing, a small world. The smallest, in fact, of all the planets that would eventually circle this particular star. And even calling it small feels like an understatement, because to stand on Mercury and look up at the black sky above you would be to understand in your bones what it means to be at the very edge of things, at the border where the solar system's warmth becomes almost too much to bear, and where the darkness of space waits just beyond the reach of the firelight. Mercury is not much larger than our own moon. If you could place them side by side, you might almost mistake them for siblings. The same pocked and cratered faces, the same ancient silences written into their surfaces, the same sense of having witnessed the very beginning, and then simply remained, unchanged like a photograph left too long in the light. Earth's moon is a companion, a familiar presence in our night sky, something we have watched rise and fall since our earliest ancestors looked upward and wondered. Mercury is something altogether lonelier. It has no moon of its own. Nothing orbits it. It travels its path around the sun in absolute solitude, closer to that blazing center than any other world, and yet somehow colder in its loneliness than the distance might suggest. To orbit the sun, as Mercury does, is to live a very compressed and intense kind of existence. A single year on Mercury, one complete journey around the sun, takes only 88 of our Earth days. 88 days to travel the whole circuit, to return to the same point in space and begin again. And yet, strangely, paradoxically, a single day on Mercury is far longer than its year. Because of the peculiar way Mercury rotates, slow and deliberate and almost reluctant, a full day on that planet, from one sunrise to the next, lasts approximately 59 Earth days. Imagine that for a moment, if you can. the sun rising above the cratered horizon, and then barely seeming to move at all, inching across the sky, hanging there, enormous and overwhelming, while days and weeks pass on Earth below. And then, after nearly 2 months of sunlit exposure, the long night finally falls, and that is when the real cold arrives. There is almost no atmosphere on Mercury. A few thin wisps of gas, barely enough to count as anything at all. Atoms of sodium and oxygen and hydrogen constantly swept away by the solar wind and replenished just as quickly, never accumulating into anything as substantial as a sky. Without an atmosphere to hold warmth, the planet cannot remember what the sun has given it. The moment the sun sets, the heat simply rises away into space, leaking out into the void with nothing to slow it. And so the surface, which only hours ago, in geological terms at least, was basking under the direct fire of the nearest star, begins to fall into a cold so profound it seems almost impossible. The temperature plunges and plunges, down through zero, down through the cold of mountaintops. Down through the cold of Antarctic winters. Down past the temperatures where ordinary machines begin to fail, down to 180 degrees below zero on the Celsius scale. A cold so deep, it feels almost violent in its contrast to what came before. And what came before was extraordinary in its own right. During the long Mercury day, when the sun hangs enormous and unyielding in that dark and nearly empty sky, the surface temperature climbs to 430 degrees Celsius. 430. That is hotter than the melting point of lead. Hot enough to liquefy certain metals. Hot enough that if you could somehow survive the cosmic radiation and the vacuum and all the other hostilities of that environment, you would still need to contend with a world that is essentially, at noon, very close to a furnace. And then the night arrives, and that same world becomes, within the span of a relatively short time, one of the coldest places in the inner solar system. The same ground. The same rocks, the same craters, swinging between extremes that no living thing, as far as we know, has ever had to endure on a single surface. There is something almost meditative about imagining Mercury's slow rotation beneath that relentless sun, the way a shadow might creep across a crater wall over the course of days. The way a single boulder might sit in the sunlight for weeks, heated through and through, and then spend just as long in the absolute cold of the shadow. The surface of Mercury is ancient and still covered in craters laid down over billions of years by the collisions of the early solar system, a time when space was far more crowded with debris than it is today. And the inner worlds wore the evidence of every impact like scars accumulated in childhood. Those scars remain because there is no rain, no wind, no geological activity significant enough to erase them. Mercury has kept its history written in stone, unchanged and enduring, and some of those scars are extraordinary. The Caloris Basin is perhaps the most dramatic feature on the planet's surface, a vast circular depression nearly 1,550 kilometers across, ringed by mountains that rise several kilometers above the surrounding plains. 1,550 kilometers. To give that scale some meaning, if you place the Caloris Basin over a map of North America, it would stretch from roughly the middle of the continent to the eastern coast. It was created by an impact so immense that the shock waves from the collision traveled all the way around the planet, meeting on the opposite side with such force that the terrain there buckled and rippled upward into what geologists call chaotic terrain, a landscape of hills and valleys thrown up by an energy wave that had circumnavigated an entire planet. Even in stillness, Mercury carries the memory of ancient violence. And beneath all of that, beneath the cratered plains and the shadowed valleys and the long, silent stretches of rock that have known nothing but extremes for billions of years, there is something unexpected, something that surprised scientists when they first began to understand what Mercury was made of. The planet's iron core, the dense, metallic heart of it, is disproportionately large by any standard we might apply. It accounts for approximately 85% of the planet's radius. 85%. In most of the terrestrial worlds, the core is significant but not dominant. On Earth, for instance, the core is large, but the planet also has a substantial mantle and crust surrounding it, layers of rock and material that make up a meaningful portion of the whole. Mercury is different. Mercury is, in a sense, almost all core. A great iron heart wrapped in only the thinnest shell of rock, like a plum whose stone has grown to fill almost the entire fruit. Why this is so remains one of the more intriguing questions in planetary science. One leading idea suggests that Mercury, in its very early history, was struck by a large impacting body that stripped away much of its outer rock, leaving the dense iron core far more exposed and dominant than it otherwise would have been. Another possibility is that the intense solar radiation during the early solar system simply evaporated much of the lighter material that originally formed Mercury's outer layers, leaving the heavy iron behind. Or perhaps Mercury formed in a region so rich in iron-bearing materials that it was simply always destined to be this way, a planet built from the heavier stuff. Close to the sun, where the lighter gases and ices never stood a chance of condensing. The answer is not yet entirely certain, but the fact remains. Mercury is a world with an enormous iron heart beating at its center, quietly generating a magnetic field weaker than Earth's, but present and real as that great core continues its slow primordial motion in the dark interior of the smallest planet. There is something almost touching about Mercury's magnetic field, something tender about it, because a magnetic field requires a planet's core to be at least partially molten, at least partially active, still processing heat from deep within. Mercury's field is a whisper compared to Earth's, a gentle suggestion of the same forces that protect our world from the solar wind, but a suggestion nonetheless. It means that even this small, ancient, battered world is not entirely cold inside. Even Mercury, the closest planet to the Sun, and yet in many ways the most desolate, has a warmth at its center that it has carried since the beginning. Since the days when those first grains of iron came together in the inner part of the solar nebula, drawn toward each other by forces older than any story, and began the slow work of becoming a planet. To think about Mercury before sleep is to think about extremes held in stillness, the extraordinary heat and the extraordinary cold, and between them the long, slow passage of days that last longer than months, and a sky so dark in the daytime that you would be able to see the stars, even with the sun blazing nearby, because without an atmosphere to scatter its light, the sun simply shines, intensely and directly, and the rest of the sky remains the deep black of space. Imagine that sky, that black and star-filled sky with the sun in it, enormous and close, and the ground beneath you alternating between infernal heat and impossible cold, depending on nothing more than whether the shadow line has moved across your position yet. Mercury is quietly extraordinary in the way that extreme things sometimes are when they have had enough time to become familiar with themselves. It does not announce its strangeness. It simply is. The craters do not proclaim their age. The iron core does not announce its improbable size. The Caloris Basin does not call attention to the ancient violence of its creation. Everything on Mercury is simply there, in the way that old things are simply there, present, enduring, patient, stripped of everything unnecessary by the long passage of time and the relentless proximity of the fire. And if you let your mind drift toward it tonight, this small iron-hearted world moving in its tight ellipse around the sun, closer to that star than we will ever be, you might find something almost peaceful in its starkness. The way a desert is peaceful, the way a place that has been stripped to its essentials has a kind of clarity to it. No softness, no complications, just rock and shadow and light and cold and heat, cycling endlessly slowly, across a surface that remembers everything and changes nothing. Mercury has been traveling its path for 4.5 billion years. Before there was life on Earth, before there were oceans on Earth, before our own world had finished gathering itself and cooling and deciding what it would eventually become, Mercury was already there, already orbiting, already accumulating its craters and carrying its iron heart and enduring its long days and its brief years. There is a kind of companionship in that thought, perhaps, a kind of comfort in knowing that the solar system's smallest world has been quietly going about its business for longer than anything we can easily imagine, and that it will continue to do so. Long and slow and stark and extraordinary, for longer still. Let that image settle as your breathing slows. Mercury's sun enormous on the horizon, the shadow line moving imperceptibly across ancient rock, the temperature beginning its long, patient fall toward the cold of a night that will last for weeks. And somewhere beneath all of that, the iron core still warm, still turning, still quietly keeping the small magnetic whisper that tells you this world has not yet gone entirely to stillness. Not yet. There is still something moving deep inside in the heart of the smallest planet, where the first materials of the solar system gathered themselves together and made something enduring from what they found close to the fire. Yet just beyond Mercury's scorched and silent plains, drifting in a slightly wider arc around the sun, lies a world cloaked in such thick and swirling clouds that for centuries no human eye could glimpse what lay beneath. A planet nearly our twin in size, and yet so utterly different that it almost seems like a mirror cracked at the moment of creation, reflecting back something familiar and yet deeply, profoundly wrong. Venus. Even the name carries a kind of soft enchantment, borrowed from the goddess of love and beauty, named perhaps for the way it gleams in the early evening sky like a lantern hung just above the horizon. Steady and radiant and impossibly lovely. You have likely seen it yourself without even knowing what it was. That bright, unhurried star that does not twinkle, that holds its glow with such quiet confidence while everything around it flickers and dances. That is Venus. And from here, from the cool and comfortable distance of a clear night and an upturned face, it is one of the most beautiful things the sky has to offer. But beauty, as the universe so gently reminds us again and again, is a thing best appreciated from a distance. Let yourself imagine floating toward Venus now, drifting through the dark on a slow and dreamlike current of curiosity. For a long while, the journey is peaceful. The sun behind you grows smaller by degrees, and ahead, Venus swells from a bright point of light into something larger, something that begins to take on shape and substance. And at first, it is breathtaking. Venus is wrapped in clouds, thick and continuous clouds that cover the entire planet without gap or break, layer upon layer of pale golden and creamy white, swirling in slow, grand spirals that seem almost gentle from above, almost soft, like the surface of warm cream stirred by an invisible hand. There is something hypnotic about those clouds. They catch the sunlight and scatter it, giving Venus that brilliant luminosity that has made it the brightest natural object in our night sky after the moon itself. For a long time, those beautiful, impenetrable clouds were the only face Venus ever showed to anyone watching from Earth, and people dreamed about what might lie beneath them. Some imagined lush jungles. Some imagined ancient oceans. Some imagined life. The clouds, it turns out, were keeping a secret, and it was not a gentle one. As you drift closer, something begins to feel different. The light changes. That golden warmth in the clouds starts to seem less like sunlight filtered through mist and more like the color of something warning you away. The clouds thicken. You are moving into them now, and the world around you narrows into a pale, diffuse amber glow, as though you have slipped inside some vast and ancient lantern. The air here is not really air at all. It is mostly carbon dioxide, almost entirely carbon dioxide, making up about 96% of this dense and pressing atmosphere. With the remainder a scattering of nitrogen and trace gases that do very little to soften the strangeness of the place. And floating through these clouds, carried by the high winds that race around the planet in just a few Earth days, even while the surface below barely moves, are droplets of something that should make your skin prickle even in a dream. Sulfuric acid. The clouds of Venus are made of sulfuric acid, drifting in great invisible curtains through the upper atmosphere and the rain that falls from them. The slow and heavy rain that you might picture in your mind as it descends never reaches the ground. It evaporates before it arrives, vaporized by the heat that rises from below, never touching the surface, endlessly cycling in those bright and lethal skies. Let yourself breathe slowly now as we move through this, because even imagining Venus should be done gently at a careful remove, the way you might watch a fire from across a room and find it beautiful precisely because you are not inside it. Deeper you go through the layers of cloud, and the weight of things begins to press inward. That thick atmosphere of Venus does not sit lightly on the world beneath it. It presses down with a force that is almost incomprehensible in human terms. The atmospheric pressure at the surface of Venus is roughly 92 times that of Earth's surface pressure. To feel something like that, you would need to descend into Earth's ocean to a depth of around 900 meters, to sink into the dark and crushing deeps, where light no longer reaches and the weight of all that water above presses in from every direction with a slow, enormous patience. That is the air on Venus. That is simply the air, resting on the ground, heavy as an ocean, thick as a secret. The few spacecraft that have ever managed to reach the Venusian surface, Soviet probes sent in the brave and determined spirit of exploration, survived for only minutes before the pressure and the heat dismantled them, sending back a handful of photographs and measurements before falling silent, claimed by a world that does not receive visitors easily. And the heat. Let us speak of the heat. If you have been following our quiet journey through the solar system, you might remember that Mercury, that sun-scorched and airless little world we passed just a moment ago, reaches temperatures that could melt, lead on its sunlit side. You might expect then that Venus, sitting a little farther from the Sun, would be somewhat cooler. And this is where Venus performs its most startling trick, the one that has fascinated and unsettled planetary scientists ever since we were first able to measure it. Venus is not cooler than Mercury. Venus is hotter, significantly, dramatically, almost philosophically hotter. The average surface temperature on Venus is around 465 degrees Celsius, not on the sun-facing side, not at the equator during peak hours. Everywhere, the entire surface of Venus maintains this extraordinary heat, day and night, pole to pole, with very little variation, whereas Mercury swings wildly between scorching days and freezing nights because it has no atmosphere to hold the warmth. Venus locks its heat in with that crushing blanket of carbon dioxide and never lets it go. This is the greenhouse effect taken to its most extreme and breathtaking conclusion. Sunlight filters in through the clouds, warms the surface, and then cannot escape. It bounces between the ground and that thick insulating sky and builds and builds and builds until the rocks themselves glow faintly in the infrared, until the landscape simmers in a heat that has nowhere to go and nothing to cool it. It is worth sitting with that for a moment. 465 degrees on average, hotter than the surface of Mercury. Despite being nearly twice as far from the Sun, it is one of the most eloquent demonstrations in all of astronomy that distance from a heat source is not the only thing that matters. What you surround yourself with matters too. What you hold in and what you let escape. Venus is a lesson written in fire, a story told in carbon dioxide about what happens when warmth cannot be released, when balance tips and keeps on tipping, when a world breathes in and cannot breathe out. But perhaps the strangest thing about Venus, the detail that settles in the mind and refuses to leave, the fact that you might find yourself thinking about just before sleep comes to find you, is not its heat or its pressure or its acid clouds. It is the way it moves. Every world we know spins as it travels, turning on its axis in a motion so fundamental to the nature of planets that we barely stop to question it. Earth spins toward the east, and that is why the sun rises in the east, swept upward by our turning world into the waiting sky. Most planets spin in this same general direction, the same direction they orbit the sun, a legacy of the vast rotating cloud of gas and dust from which the solar system was born long ago. But Venus does not spin that way. Venus spins backwards. If you could stand on the surface of Venus and wait for the sun to rise, which would be an extraordinary act of patience, as we will explain in a moment, you would see it climb above the western horizon, not the eastern one. The sun on Venus rises in the west and sets in the east, the inverse of everything we know on Earth, a kind of dreaming logic that belongs to another kind of world. Scientists call this retrograde rotation, and there are theories about how it came to be. Perhaps a massive ancient collision that tilted and reversed Venus's spin long ago. Perhaps some gravitational interaction in the deep past that gradually wound it backward like a clock, turned the wrong way. Whatever the reason, Venus now moves through its own time in reverse, gentle and unhurried, and utterly indifferent to the conventions of the rest of the solar system. And the unhurried part is worth dwelling on. Venus rotates so slowly, so extraordinarily slowly, that a single day on Venus measured as a full rotation on its axis takes about 243 Earth days to complete. That is longer than a Venusian year. Venus travels all the way around the Sun in about 225 Earth days, meaning that the planet finishes its entire journey around the star before it has even managed to turn all the way around once. On Venus, your birthday would come before your next sunrise. Time moves differently there, in that heavy amber air, in that deep and pressing quiet beneath the clouds. And there is something almost meditative about it. Something that asks you to reconsider what a day means, what a year means, what the ticking of time feels like when the world beneath your feet can barely be bothered to turn. We called Venus Earth's twin, and in the cold mathematics of size and mass, the name fits well. Venus is very nearly the same size as our world, and its mass is close enough to Earth's that the gravity you would feel on its surface would be only slightly less than what you feel right now. If you could somehow hold the two planets side by side in the palm of some enormous cosmic hand, you would see two worlds that look almost identical in their basic proportions. Two rocky spheres of very similar weight and dimension, born from the same swirling material in the same corner of the same young solar system. They are siblings in a sense. They grew up together, formed in the same neighborhood, built from much the same ingredients, and yet they went such different ways. Earth became oceans and storms and forests and sleeping creatures and the particular quality of afternoon light through leaves. And Venus became a crushing oven wrapped in poisoned clouds, become a world where no water can rest on the surface, where no living thing we have ever imagined could survive, where even spacecraft arrive only to be slowly destroyed. What happened? What turned the twins so different? It is a question that planetary scientists hold with real tenderness, because the answer may matter more than we like to think. The best current understanding suggests that Venus may have once had oceans, real oceans, liquid water oceans, long ago when the sun was younger and cooler and the surface temperatures were perhaps low enough to allow it. But as the sun warmed, as Venus's oceans began to evaporate, the water vapor in the atmosphere added to the greenhouse effect, warming the planet further, evaporating more water, warming it further still in a cascading loop that could not be stopped. A runaway greenhouse effect that consumed whatever moderate climate Venus once might have had and replaced it with the furnace world we find today. All that water eventually broke apart in the upper atmosphere, its hydrogen atoms drifting away into space, and Venus was left dry and airless and burning. A world that once might have been something else entirely, now sealed beneath its amber sky in a long and changeless heat. There is something in that story that asks for quiet reflection rather than alarm, approached in the soft and careful way that bedtime thoughts deserve. It is a story about thresholds, about the moments when a system tips from one state into another and cannot easily return. Venus keeps that story pressed beneath its clouds like a letter that cannot be unwritten, and there is a reason why those who study climate and atmosphere keep their eyes on Venus with such thoughtful attention. It is not a cautionary tale told with a pointed finger. It is simply a truth written very large and very bright in the sky just past sunset, hanging there patient and luminous for anyone who wants to look. And if you find yourself on a clear evening, standing outside in the cooling air, and you see that steadfast bright light above the horizon that does not flicker, that holds its glow with such serene and ancient confidence, you can let yourself feel both things at once, the beauty of it, which is real, which is undeniable, which has inspired poets and lovers and dreamers for as long as humans have looked up, and the strangeness of it, which is equally real, which lies beneath those glowing clouds in the form of acid rain that never lands and rocks that simmer in the dark, and a sun that rises in the wrong direction over a world that spins backward through its own impossibly long and silent days. Venus does not ask for your fear. It only asks, perhaps, to be truly seen, not just as the pretty light above the rooftops, not just as a name borrowed from beauty, but as itself, as this improbable and extreme and somehow magnificent world that shares our neighborhood and our origins and almost nothing else, that followed a different road through the same beginning and arrived at something we could never have predicted. Something that reminds us how many ways there are for a rocky world to be. How many different endings the same kind of story can reach. Let your breathing slow a little now. Let the image of Venus settle in your mind. That warm amber glow, those high fast clouds of cream and gold, that deep and pressing quiet below them. That slow backward, turning under a sky with no blue in it anywhere. No rain that reaches the ground, no morning that comes before a year has passed. It is strange and it is beautiful and it is completely, utterly itself, and there is a kind of peace in that, in the way Venus simply is what it is, without apology, without explanation. Sealed in its own particular mystery beneath those gorgeous poisoned clouds. And while Venus spins in its strange, slow backward dream beneath those amber clouds of sulfur and carbon, there is one more world in this neighborhood of the sun whose oceans carry something neither Mercury nor Venus ever had. A world of blue water and breathing things. A world that is, of course, home. Our home. The only one we have ever known. Close your eyes for a moment if you like, and imagine the view. Imagine rising up slowly. The way a soap bubble rises on a warm summer afternoon, drifting higher and higher until the ground beneath you becomes a patchwork of green and brown, until the coastlines begin to curve, until the atmosphere, that thin, gossamer veil of air we breathe without thinking, becomes visible as a soft, luminous halo clinging to the edges of the world. And then, from high above, the whole thing resolves into something almost unbearably beautiful. A sphere, a living sphere, blue and white and green and gold, turning slowly in the velvet silence of space, wrapped in swirling clouds that move like brushstrokes across a painting that never quite dries, always changing, always becoming something new. From space, our world looks blue, almost entirely blue. And this is not an accident of light or a trick of atmosphere. It is a true reflection of what Earth actually is, a water world, a place where the oceans cover roughly 71% of the surface, where liquid water fills the basins of ancient seafloors, where tides move in and out along 10,000 different shores, carrying with them the slow, patient work of a planet that has been at this for a very long time. Think of that for a moment. Gently, without rushing, nearly 3/4 of the world you were born on is ocean. The continents, those familiar shapes you traced as a child, the boot of Italy, the long finger of South America, the wide cradle of Africa, are really just islands in a vast global sea. We are, in the truest sense, inhabitants of an ocean planet who happen to live on the dry parts. This was not always so easy to see. For most of human history, the Earth simply was the world. It was everything. The mountains and the rivers and the starry sky above were all part of one seamless, lived experience, and no one could step outside it to look back. But then, in the latter half of the 20th century, human beings began to leave. Quietly at first, tentatively, in small metal capsules balanced on columns of controlled fire. And from that new distance, something remarkable happened. The Earth became visible as a thing, a single, complete, finite, heartbreakingly beautiful thing. Astronauts have described the experience in hushed, reverent terms. The shock of seeing no borders, no flags, no lines dividing nation from nation. Only the great blue wholeness of a world that does not know it is supposed to be divided. One of the most famous descriptions of our planet from space came not from orbit, but from much farther away, from the edge of the solar system itself. A spacecraft, drifting billions of kilometers out into the dark, turned its camera back toward the sun, and there, suspended in a beam of scattered sunlight, was Earth. A pale blue dot, a mote of dust in a sunbeam. A point of light so small it could be covered by the tip of a finger held up to the sky. And yet on that tiny pixel, every human being who ever lived had their story. Every love, every loss, every song ever sung, every dream ever whispered into the darkness before sleep, all of it there, on that pale blue dot. What makes our pale blue dot so different from everything else we see when we look outward? The answer, when you trace it carefully, begins not with life itself, but with the conditions that made life possible. Earth sits in what planetary scientists call the habitable zone, sometimes called with a kind of warm affection, the Goldilocks zone, not too close to the sun, where the heat would be ferocious and unrelenting, burning away any water before it could settle, not too far, where temperatures would plunge and water would freeze solid and stay that way, but just right. At this particular distance, and with this particular atmosphere, water on Earth exists in all three of its forms, as ice, as liquid, and as vapor, cycling endlessly between them. And it is this cycling, this patient, eternal movement of water through the world that makes so much else possible. And the sun itself, that generous, steady star, provides something that Earth's distance alone could not guarantee without help. The warmth it sends is received and held by our atmosphere, that thin but vital mixture of nitrogen and oxygen and water vapor, and a careful measure of other gases. This is the greenhouse effect in its gentle, life-sustaining form, not the runaway version that scorched Venus into an oven, but a measured, balanced warmth that keeps the average surface temperature at something a living creature can endure. On a calm day, in a meadow, with the sun filtering through leaves, this is what you're feeling. The sun's energy caught and cradled by a thin layer of air. The whole history of life on Earth is, in a sense, the history of that warmth finding its way into living things. But warmth and water, as important as they are, would not be enough on their own without something that works invisibly, tirelessly, far beneath our feet. Deep inside the Earth, deeper than any well, deeper than any mine, in a region so hot and pressurized that iron itself has melted into a slowly churning liquid sea, there is a dynamo, the Earth's core, made largely of molten iron and nickel, rotates as the planet rotates, and this movement of conducting metal through space generates something extraordinary, a magnetic field, an invisible force field that extends far out into space around our planet, bending and deflecting the stream of charged particles that flows constantly outward from the sun. This is the solar wind, a relentless rain of protons and electrons and other energetic particles that, without any protection, would slowly strip away an atmosphere, erode a planet, and make the surface a hostile and barren place. We know what that looks like. We have seen it at Mars. But here, wrapped in the warm, invisible arms of our magnetic field, life is sheltered. The particles are guided away, curving around the planet in great arcs, and where they meet the upper atmosphere near the poles, they give us one last gift, the auroras, the northern and southern lights. Those trembling curtains of green and violet and white that dance above the high latitudes on winter nights, a visible signature of the invisible shield that keeps us safe. Earth is also, among all the worlds in the solar system, the densest. If you could gather all the material of our planet and weigh it against an equivalent volume of water, you would find that Earth is 5.5 times denser, 5.51 grams per cubic centimeter, to give it its precise and almost musical number. This density speaks to composition. Earth is rich in iron and other heavy elements, layered like an onion from the thin crust beneath your feet through the rocky mantle and down into that liquid outer core and the solid inner core at the very center. This layered structure, this differentiation of materials into shells of different density, is itself a sign of a planet that has been geologically alive for billions of years. A planet that has melted and solidified and churned and resurfaced itself over and over, driven by the heat of its own interior. A planet still breathing in its slow geological way. And then there's the moon, our moon, that familiar silver face that has watched over every nighttime in the history of human memory, that has pulled the tides in and out along every shore, that has given poets their favorite subject and navigators their oldest clock. The moon is large for a satellite, unusually, perhaps even improbably large relative to the planet it orbits. And this size matters more than you might expect, because the moon acts as a gravitational anchor for the Earth's tilt. Our planet is tilted about 23.5 degrees relative to its orbit around the sun, and it is this tilt that gives us our seasons. The way sunlight falls more directly on the northern hemisphere in summer and more obliquely in winter. Without the moon's steadying gravitational influence, that tilt would not stay fixed. It would wander, shifting over thousands of years through a wide range of angles, and with it, the climate of the planet would lurch and swing through extremes that might have made long-term biological evolution enormously more difficult. The moon, in its quiet way, has been a partner in the stability that allowed life here to grow complex over billions of years. It holds the world steady enough for slow, patient things to unfold, for single cells to become many-celled creatures, for creatures to develop eyes and limbs and curiosity, for one particular kind of curious creature to eventually look up at that same moon and begin to wonder what it was. Life. That is the word that makes Earth unlike any other world we have yet found. We have searched, and we continue to search with every instrument we can devise, and so far in all the vast cold dark of the cosmos. Only this one small blue world has yielded unambiguous evidence of living things. Not just simple things, though the simplest things here are themselves extraordinary. The single-celled organisms that dwell in hot springs and deep ocean vents and frozen Antarctic ice. The bacteria that breathe sulfur or eat iron or thrive in conditions that seem designed to be uninhabitable. But here also trees, moss, coral reefs, whales moving through deep water, birds crossing oceans on invisible pathways written into their bones, children sleeping, the whole warm, improbable, unimaginably intricate web of life that has wound itself through every corner of this planet's surface into the soil and the air and the sea, finding purchase wherever the conditions allow, adapting, enduring, persisting with a tenacity that is both fierce and quiet. It is possible, when you think about this from a sufficient distance, to feel the sheer improbability of it, the precise distance from the sun, the right composition of atmosphere, the presence of water, the active geology that keeps nutrients cycling through the system, the magnetic field, the stabilizing moon, the density and mass of the planet itself, large enough to hold an atmosphere, small enough not to be a gas giant. Each factor alone would not be enough. All of them together, woven into a single world, produce something that so far appears to be genuinely rare: a living planet. A place where the chemistry of molecules became the chemistry of cells, and the chemistry of cells became the chemistry of thought. And the chemistry of thought eventually looked up at the stars and felt wonder. There is something tender in thinking about this, especially in the quiet hours when the world outside has settled into stillness. The Earth goes on turning, as it has for more than 4.5 billion years, at the same patient pace. The oceans breathe in and out with the tides. The atmosphere stirs itself into weather. The core churns in its depths, keeping the magnetic shield alive. And on the surface, under a sky that is blue because of the particular way oxygen and nitrogen scatter sunlight, a sky that is truly, genuinely blue only because of life. Living things sleep and grow and reach toward the light. From space, at the right hour, you can see the lights of cities scattered across the dark side of the planet like embers, like a civilization seen from an enormous distance, which is exactly what it is. You can see the white coils of storms over the oceans. You can see the deep greens of forests. You can see the long, bright line of a coastline where the land meets the sea, and all of it, every light, every cloud, every shore, hangs in the darkness, not because it has anywhere to hang from, but simply because it is there, part of a system so finely balanced, so quietly perfect in its imperfection that it beggars any easy description. This is where you come from, this luminous, breathing, turning thing, this pale blue dot with its swirling white clouds and its magnetic embrace and its great patient oceans and its single steadying moon. This densest of all the solar system's rocky worlds, this warmest miracle in the cold, dark neighborhood of the sun. Every breath you have ever taken came from this planet's air. Every drop of water you have ever drunk fell first as rain from these clouds. You are, in a very literal and beautiful sense, made of earth. And when you sleep tonight on a bed, on a floor, in a house, on a continent, on a planet in the habitable zone of an ordinary star, you are resting in the arms of the only home any of us has ever known. There is no need to rush this feeling. Let it settle like dust settling in still air, like snow falling softly on a field at night. The world is turning and you are on it, and for this moment that is enough. The oceans are moving somewhere in their deep, slow currents. The aurora is perhaps shimmering tonight above someone standing in a cold field, looking up with their breath, making small clouds in the dark. The moon, that ancient companion, is somewhere in its orbit, pulling gently on the tides, holding the planet's tilt steady, doing its quiet, necessary work. And you are here, breathing the same air that breathing things have breathed on this planet for hundreds of millions of years, held to the surface by the same gravity that holds the oceans in their basins, warmed by the same star that has risen every morning of Earth's long history. Let that warmth reach you now, soft and unhurried. Let the image of that blue world turning in the dark be the last clear thing before thought begins to soften and dissolve into the first gentle currents of sleep. You're home. You have always been home, and the universe in all its vastness has one small luminous corner where life decided to try, And as we imagine drifting gently away from that small blue island of life, watching its lights and clouds grow smaller in the dark, we turn our gaze just a little further outward, toward a rust-colored neighbor whose thin, dusty skies hold the longest-standing question in all of planetary science, whether life ever stirred beneath those ochre skies, whether something small and ancient once moved through shallow water on a world that has since forgotten what water felt like. Mars is not the closest planet to us, nor the largest, nor the brightest in the night sky on most evenings, and yet it has always called to us in a way that feels almost personal. Perhaps it is the color, that particular shade of rust and iron, warm even from a distance, like the glow of a dying ember in a dark room. Perhaps it is the way it moves across the sky with a kind of slow purpose, unhurried, observant. Whatever the reason, humanity has been watching Mars for thousands of years, telling stories about it, dreaming about it, and now, at last, sending small mechanical ambassadors to roll across its surface and listen for whatever the planet might still be willing to say. If you were to arrive at Mars quietly, drifting down through its thin and rosy atmosphere, the first thing you might notice is the silence. Not the silence of a vacuum. Not quite, because Mars does have an atmosphere, though it is so thin and so cold that it would offer little comfort. The air there is mostly carbon dioxide, less than 1% of the pressure we breathe here on Earth, and it carries with it a constant whisper of iron-tinged dust. The sky above the Martian surface is not the deep, clean blue we know. It is something softer and stranger, a pale butterscotch on clear days, shading toward muted pinks and lavenders near the horizon, and on stormy days, a deepening amber that dims the sun to something gentler than memory. You might stand there in a dream and feel as though you had arrived somewhere. You had always almost known. The days on Mars would feel familiar in their rhythm, and that is one of the quiet marvels of this world. A Martian day, which scientists call a sol, lasts 24 hours and 37 minutes, just slightly longer than a day on Earth, as though time itself breathes a little more slowly here. The rovers that have trundled across Martian soil, those faithful robotic explorers, operate on Martian time. They're human controllers on Earth, adjusting their own schedules to stay in rhythm with another world's sun. There is something tender about that image. People on Earth rising and sleeping according to a sun they cannot see, on a planet they have never touched. Out of devotion to small machines making slow and careful progress across the rust. The sol ticks by on Mars much as a day ticks by here, sunrise and sunset, light and shadow, the long quiet in between. But though the rhythm of days may feel like home, the scale of Mars would quickly remind you that you are somewhere else entirely, to the west. If you were standing in the right place, you might see the faint swelling of a horizon that rises too high, that curves upward in a way that makes no sense until you understand what you're looking at. Olympus Mons stands 22 kilometers high, roughly 22,000 meters above the surrounding plains, and it is the tallest volcano in the entire solar system. To call it a mountain feels insufficient, and yet it does not look the way you might expect. Because it is so vast, so enormously wide at its base, stretching more than 600 kilometers across, it is actually too large to see all at once from the surface. If you stood near its edge, you would not see a dramatic peak looming above you. You would simply notice that the ground rises and keeps rising, impossibly gently for hundreds of kilometers, until you are standing in thin air above most of the Martian atmosphere, and the curvature of the planet itself is just barely visible at the edges of the world. Olympus Mons is a shield volcano built not in one explosive moment, but over billions of years of slow, patient eruption, lava flowing outward and hardening and being covered by more lava. Layer upon layer, like the rings of a very old tree, it is almost certainly dormant now, quiet and cold, the magma chambers beneath it having cooled and stilled long ago. But there is something haunting about standing at the foot of something so permanent, so immovably ancient. It has been there longer than our oceans have looked the way they look, longer than our mountain ranges have worn their current shapes. It will almost certainly still be there long after every range and ridge on Earth has been ground down to flatness. Olympus Mons keeps time in a language older than anything we have names for, and Mars keeps other ancient records too, if you know where to look. Scattered across its surface, carved into the rock and hidden beneath the dust, are the traces of something that once was and is no longer, a history of water. Not the frozen water that still exists in the polar ice caps, not the ice that sleeps beneath certain regions of the Martian crust, but something older and warmer and more generous. Ancient river valleys wind across the Martian terrain, their shapes unmistakable to anyone who has traced a river across a map of Earth, broad and branching, cutting downhill through the stone, depositing sediment in curves that only moving liquid makes. There are dried lake beds, their floors smooth with the kind of sediment that only settles out of water that stood still and deep for a very long time. There are minerals in the Martian rock, clays and carbonates and sulfates that only form in the presence of liquid water. The planet is trying to tell us something, writing in its stone the memory of rain and rivers and standing lakes. This was Mars perhaps 3 to 4 billion years ago, a world that was warmer, with a thicker atmosphere, with water flowing across its surface and collecting in basins that might, just might, have been habitable. The question that haunts every Mars scientist, every late-night dreamer who has ever looked up at that red point of light in the night sky is what happened next, and whether, in those ancient, warm and wet millennia, something had enough time to begin. Life on Earth started remarkably quickly once the conditions were right. Could the same have happened on Mars? Could something small and microscopic have stirred in that ancient water, learned to metabolize, to divide, to persist? And if so, where did it go when the water retreated? When the atmosphere thinned, when the cold came? There is no answer yet. The question remains open, patient, and enormous, like a door left slightly ajar in an empty house. Each rover that lands on Mars is, in some sense, leaning through that door and listening. The Perseverance rover has been collecting samples from an ancient river delta, Jezero Crater, which was once a lake, carefully drilling into rock that was laid down in water and sealing the cores in small titanium tubes for a future mission to bring home. We have not yet found the answer, but we are getting closer to the right kinds of rocks, the kinds that might have preserved whatever was there, if anything was. In the meantime, Mars offers its own kind of beauty, its own quiet drama. The planet has a face that changes. Not the slow change of tectonic drift or erosion, but the swift and dramatic change of wind and dust. Mars experiences storms, not the gentle afternoon thunderstorms of a summer Earth, not even the great hurricanes that spiral over our oceans, but something far more encompassing, something that does not have a proper comparison in any human experience. planet-wide dust storms. Every few Martian years, under conditions that scientists still do not fully understand, the winds of Mars begin to lift dust from the surface, and the dust, once aloft, absorbs sunlight and heats the surrounding air, which then rises and carries more dust, which absorbs more sunlight, in a cycle that can grow until it covers the entire globe. The whole planet disappears under a shroud of fine iron-rich dust, the sun dimming to a faint smudge, the surface hidden from any orbiting camera for months at a time. These storms can last for months. They have outlasted rovers. The Opportunity rover, which operated for 15 extraordinary years on the Martian surface, was finally silenced in 2018 when a planet-wide dust storm starved its solar panels of light. The last signal it sent before going quiet was interpreted by engineers as something close to. Its battery was low and the sky was very dark. Whether or not that interpretation is poetically exact, there is something unbearably moving about it, a small machine on a cold and distant world running out of light. Sending its last signal home across the dark. We waited for months. The storm eventually cleared. Opportunity never woke again. But other machines continue. Curiosity is still rolling slowly across Gale Crater, analyzing rocks and soil, measuring radiation, monitoring the weather. Perseverance continues its careful collection in Jezero, the Ingenuity helicopter, a tiny, impossibly delicate thing, more like a dragonfly than any human aircraft, proved that powered flight was possible in that thin Martian air. Lifting off for the first time in April 2021, in a moment that will be written into the history of exploration forever. It flew dozens of times before eventually its rotors were damaged, and it too fell silent. Mars collects its explorers. Mars keeps them. The two small moons of Mars orbit above all of this, keeping their own quiet watch. Phobos and Deimos, named for the children of Ares in Greek mythology, fear and dread, are not the grand round moons of the inner solar system. They are small and irregular, lumpy and dark, pocked with craters, looking less like classical moons and more like asteroids in borrowed orbits. And that is almost certainly what they are. Asteroids captured long ago by Mars's gravity, pulled from the asteroid belt into their current paths, where they have circled ever since. Phobos is the closer of the two, orbiting so near to Mars that it rises in the west and sets in the east, moving faster than the planet rotates beneath it. It is also slowly, imperceptibly spiraling inward, and in roughly 50 million years, it will come close enough that the tidal forces of Mars will tear it apart, scattering it into a thin ring around the planet. Mars will one day wear Phobos like a necklace. Briefly, before that too disperses into dust. Deimos is smaller and more distant, moving so slowly that it appears nearly stationary in the Martian sky, a faint, barely moving star, easy to miss, easy to overlook. From the surface of Mars, on a clear night, when the dust has settled and the sky is dark, both moons would be visible, though neither would be bright enough to cast shadows. They would be pale and small and strangely quiet above the rust-colored dunes, above the frozen silence of the ancient lake beds, above the long, slow slopes of Olympus Mons cooling in the dark. There is a particular quality to imagining Mars at night that lives somewhere between longing and melancholy. It is a world that had something, warmth perhaps, water certainly, and maybe more, and then watched it leave. The atmosphere thinned over billions of years as Mars lost its global magnetic field. And without that shield, the solar wind slowly stripped the lighter gases away into space. The water retreated underground and to the poles, or evaporated and was lost. What had been a warmer, wetter place became the cold, dry desert it is now. All that ancient story locked into rock and mineral and the shapes of dried-up riverbeds. Mars is not dead exactly, but it is dreaming, perhaps, of what it used to be. And yet the hope remains. And it is not sentimental, it is scientific. Life, once it begins, is remarkably difficult to extinguish entirely. Extremophiles on Earth survive in conditions that would kill almost anything we are familiar with, thriving in boiling acid springs and Antarctic ice, and the deep darkness beneath kilometers of ocean floor. If life began on Mars when conditions were more favorable, it is not impossible, not beyond reason, that some form of it retreated underground as the surface grew hostile, finding warmth in geothermal heat, finding water in pockets deep beneath the permafrost. We have not looked deeply enough yet. The question is still open. The door is still ajar. So Mars drifts on in its orbit, tilted slightly, spinning through its 24-hour and 37-minute days, its two small captured moons circling faithfully above. Its ancient valleys recording a history that is still being decoded, its dust rising and settling and rising again. It is a world that asks a question we cannot yet answer. And maybe that is why it has always felt like more than just a planet to us. It feels like a story we are still in the middle of, a dream we have not quite finished having. And past the red dunes and the silent calderas of Mars, past the rust-colored twilight settling over Olympus Mons each evening, lies a vast and tumbling belt of ancient rubble, the leftovers of creation. Millions of rocky fragments drifting in a slow celestial ring between the inner worlds and the great giants beyond, a place where time moves differently, where the clocks of geology and chemistry and change have been wound so slowly that they have barely turned at all in 4.5 billion years, where the debris of the very first mornings of our solar system still drifts in its patient, unhurried arcs as it always has, as it perhaps always will, circling the sun in a long and gentle ring of memory. Close your eyes and imagine yourself here, not hurtling, not rushing, but floating, just floating, the way a feather descends through still autumn air, with no particular urgency, with no destination that demands speed. You are drifting through the asteroid belt now, that wide and ancient corridor of stone that stretches between the red world you left behind and the colossal, cloud-wrapped giant still glimmering far ahead, and the first thing you notice is the silence. Not the silence of emptiness exactly, though there is so much emptiness here, more than you might expect, more than the pictures in old books ever suggested. This is a different kind of silence. It is the silence of things that have been waiting for a very long time, patiently, without complaint, without any particular wish to be disturbed. The belt begins somewhere beyond the orbit of Mars, that rust-dusted world you passed in the softening twilight of its long evenings, and it extends outward, slowly, spaciously, until it reaches the great gravitational presence of Jupiter, whose influence you can already feel in the subtle choreography of everything around you, the way each tumbling fragment knows its place, the way each orbit has been shaped and tested over eons of gravitational suggestion. Between those two worlds, Mars and Jupiter, between the small rocky planets of the inner solar system and the gas giants of the outer dark, the belt drifts and turns, a slow ring of ancient material, neither fully organized nor fully scattered, caught in a kind of eternal in-between, a liminal space that never quite resolved itself into what it might have become. There are millions of them, millions of rocky bodies, floating in this great ring, ranging from grains of dust so fine you might breathe them in without noticing, all the way up to objects large enough to have their own gravity, their own rounded shapes, their own quiet authority. And yet, for all those millions of fragments, the belt is not crowded. This is the secret that tends to surprise people when they first truly reckon with it. The images we draw, the illustrations we make of our solar system, tend to pack the asteroid belt together to make it look dense and treacherous. A field of grinding rocks through which no ship could safely pass without constant danger. But the truth is something far more spacious, far more peaceful than that. The asteroid belt is almost entirely empty space. The distances between individual asteroids are vast, measured not in meters or kilometers, but in hundreds of thousands of kilometers. Great open stretches of nothing between each drifting stone. When the early spacecraft of human exploration passed through the belt, scientists held their breath, bracing for the statistical possibility of collision, for the dangers they imagined lurking in that crowded-looking ring, and the spacecraft simply sailed through quietly, safely, passing through all that apparent density without ever coming close to a single rock, because the space between rocks is so immense, so generous, so far beyond what our earthly intuitions of crowdedness suggest, that there was never truly any danger at all. The belt is a museum, not a maze. You wander through it slowly, stopping to look, and nothing rushes at you. Nothing demands your hurry. Float with that for a moment. Let the spaciousness of it settle over you, like a quiet room at the end of a long day. Millions of rocks spread across a volume of space so large that even millions of rocks cannot fill it. There is something deeply restful in that image, something that invites a slowing of the breath, a loosening of the shoulders, a letting go of the sense that things must be packed tightly together to matter, that worth is measured in density. The asteroid belt, in its vast and patient emptiness, suggests otherwise. And now let your attention rest on the largest of the belt's inhabitants, the one that rises above the rest in size and gravity and subtle grandeur. Ceres. It was discovered on the first day of the 19th century, January 1st, 1801, spotted by an Italian astronomer named Giuseppe Piazzi, who at first thought he had found a comet, then a star, and then gradually understood he had found something entirely new, something that did not fit the existing categories, something that required a new word and a new kind of thinking. Ceres is a dwarf planet now, reclassified alongside Pluto in the great reorganization of solar system terminology, but whatever name we give it, it remains the undisputed sovereign of the asteroid belt. Roughly 945 kilometers across, nearly spherical from its own quiet gravity, Ceres contains within its rocky and possibly icy body approximately 1/3 of all the mass in the entire asteroid belt. One world, one rounded drifting presence, accounting for 1/3 of everything the belt has to offer. The rest is distributed among millions of smaller bodies, none of them coming close to Ceres in size or influence. And so Ceres floats there at the center of its domain, like a museum curator who is also quietly the most significant exhibit. When the Dawn spacecraft arrived at Ceres in 2015, it sent back images that no one had ever seen before. The closed, detailed face of this ancient world lit by the distant sun. its surface cratered and gray and old, bearing the accumulated signatures of billions of years of minor collisions, of solar radiation and slow chemical change. And there, in the images, something unexpected and wonderful, bright spots shining from within a crater called Ocketer, white and gleaming against the gray surrounding rock, caused by the slow upwelling of salty water from beneath the surface, water that rises and evaporates and leaves behind bright deposits of sodium carbonate, a ghost of an ancient ocean. A whisper of the liquid interior that still exists somewhere below the frozen surface. Even in this old and quiet place, even in this museum of ancient rubble, life finds a way to surprise. The universe does not give up its secrets all at once, and that is the deeper miracle of the asteroid belt, the one that rewards slow contemplation on a quiet night. These are not dead rocks. They are not simply debris, discarded and forgotten. They are witnesses. They are the oldest testimony we have of the way our solar system began. These fragments of primordial material that never combined, never melted, never reformed into something new. The heat and pressure and geological violence that reshaped the inner planets, that drove the continents of Earth and built the mountains of Venus and carved the canyons of Mars, never reached most of the asteroid belt in the same transformative way. Many of these rocks have remained chemically unchanged since the earliest days of the solar system's formation, more than 4.5 billion years ago. And when scientists study them, when meteorites that were once asteroids fall through the atmosphere and are collected and analyzed in careful laboratories, they are reading the original recipe, the precise mixture of elements and minerals from which everything in our solar neighborhood was cooked. There is something almost sacred about that, to hold in your hand a piece of something unchanged since before the Earth existed, since before the oceans filled or the first mountains rose or the first living chemistry stirred in the first warm pool, is to hold a piece of time itself, to touch the threshold between the now and the very beginning. The asteroid belt keeps those pieces for us, storing them in the cold and airless dark, maintaining their integrity across billions of years of quiet orbiting, as patient as a library and as old as nearly anything we know. And why did these rocks never become a planet? This is the question that shaped the asteroid belt's history, the gravitational story that explains why all this material, all these millions of fragments, never coalesced into a full world the way the material closer to the sun eventually did. The answer lies in the immense presence of Jupiter, the great giant whose gravity permeates the outer solar system the way a deep and resonant note permeates a quiet room. As the early solar system was forming, as clumps of material in the primordial disk were slowly gathering themselves together under the influence of their own mutual gravity, the region that would become the asteroid belt was already under Jupiter's influence. And Jupiter, even forming in those early days, was already large enough to disturb everything around it, tugging at the material in the belt, stirring up the orbits, preventing the gentle collisions that build worlds from becoming something more. Instead of slow and constructive coming together, the material in the belt experienced faster, more violent collisions, impacts that broke rocks apart rather than building them up, that scattered material rather than gathering it. Jupiter's gravity also gradually cleared much of the material from the belt over billions of years, scattering asteroids into the inner solar system and the outer dark and reducing what was once a much more massive reservoir of material to the relatively sparse ring that drifts there now. What remains is perhaps a small fraction of what was originally present, a remnant of a remnant, the surviving pages of a book that was never finished, never fully written, held together in a loose and patient collection by the slow and quiet balance between the sun's gravity and Jupiter's interruptions. So the asteroid belt is, in a sense, Jupiter's creation, not made by Jupiter, not formed from Jupiter, but shaped definitively by that giant world's presence, the way a river is shaped by the hills it cannot cross, the way a life is shaped by the obstacles that redirected it towards something unexpected and ultimately more interesting than the original plan. Without Jupiter, the belt might have become a planet, another rocky world circling in the outer reaches of the inner solar system. With Jupiter, it became something stranger and more beautiful, a vast archive, a floating library of beginning, a ring of memory that circles the sun in quiet contemplation of everything that came before. Let yourself drift through it one more time before we leave it behind. The rocks turning slowly in the pale sunlight, each one casting its own tiny shadow into the dark, each one carrying within its chemistry some fraction of the original story, some mineral signature of the first moments. Ceres, round and patient and bright-spotted, holding its third of everything, drifting in its steady orbit. The dust, the grains, the pebbles, the boulders, the mountains without planets to stand on, all of them circling, all of them waiting, all of them simply being what they have always been, unhurried, unchanged, ancient, beyond ordinary comprehension. There is no better place for the mind to rest than in this kind of spaciousness. No rush, no urgency, just the slow drift of stone in the dark, the barely perceptible arc of each orbit, the sun a bright point in one direction and the great outer darkness extending in every other. Breathe with the belt for a moment. Let your thoughts lose their edges, the way the stars lose their edges when you let your eyes go soft. You are part of a solar system that has been turning for 4.5 billion years, and in those billions of years, the asteroid belt has been here the whole time, quietly watching, quietly remembering, quietly being, and it is that same vast gravitational presence, Jupiter's immense and steadying pull, that shapes so much of what happens in the outer solar system. For just beyond the last tumbling rocks of the belt, that colossal world appears at last like a lantern in the dark, so enormous that the mind, even resting quietly on the edge of sleep, struggles to hold the whole of it at once. And perhaps that is fitting. Perhaps some things are simply meant to exceed us, to stand at the threshold of comprehension and invite us not to understand them fully, but simply to feel them. The way you feel a cathedral, the moment you step inside and your breath goes still and the ceiling rises above you like a sky within a sky. Jupiter is that kind of place. A world that does not ask to be measured so much as witnessed. It is the largest planet in our solar system, and that word, largest, does not quite do the work it needs to do. We use that word for mountains and for oceans and for the wide arms of ancient trees, but here it means something different entirely, something that requires a different kind of listening. Jupiter is so massive, so incomprehensibly vast in its proportions, that if you were to gather every other planet in our solar system, every single one, Mercury and Venus and our own beloved Earth, Mars with its red dust and thin cold air, Saturn and Uranus and Neptune, every last one of them, and place them all together, you would still only fill half of Jupiter's volume. All of them combined could fit inside it twice over and leave room still, as though Jupiter were a palace and all the other worlds were guests who barely filled the hallway. And yet for all that scale, for all that immensity, Jupiter does not lumber. It does not move the way you might imagine something so large would move, slowly and ponderous as a continent drifting across a forgotten sea. No, Jupiter spins. It spins faster than any other planet in the solar system, completing one full rotation in just under 10 hours. 10 hours. Our own Earth, so much smaller, takes 24 to make the same journey around its axis, and yet Jupiter, with all its vastness, with all its billions upon billions of miles of swirling gas, turns itself around in less than half that time. There is something almost dizzying in that thought, something that makes you want to close your eyes and simply let it settle, the way you let a dream settle when you first surface from sleep and find it still hovering there at the edges of your mind, vivid and strange and beautiful. And it is made this great spinning world of the simplest and oldest materials the universe knows how to make. Hydrogen and helium, the first two elements, the building blocks that emerged from the earliest moments of existence when the universe was still young and hot and learning the shape of itself. Jupiter is composed almost entirely of these two gases, a swirling, layered, impossibly deep atmosphere of hydrogen and helium that descends inward for tens of thousands of miles, growing denser and hotter and stranger the deeper you go, until somewhere in its hidden heart, under pressures we have no earthly experience to compare with, hydrogen itself transforms into something metallic, something conducting, something that carries electric currents and generates the most powerful magnetic field of any planet in our solar system. But the surface, the thing we imagine standing on, the solid ground we instinctively reach for in our minds when we think of a world that does not exist here. There is no surface to land on, no ground beneath your feet. Jupiter is a giant ball of gas, and it simply continues inward, layer after layer, pressure after pressure, and if you were to fall into it, you would not land, you would only descend. The air thickening around you, the light fading, the world pressing in from every side as though the planet itself were breathing you in. There is something almost meditative about that image when you hold it gently, without fear. A world with no edges, a world that is all interior, all depth, all the way down. But we do not think of Jupiter's depths when we first turn our eyes toward it in the night sky or study those luminous images returned to us by the faithful probes we have sent out across the solar system. We think of what we see on the outside. We think of those bands, those glorious sweeping bands of amber and ochre and pale cream and deep russet brown bands of cloud that wrap around the planet in long horizontal rivers, driven by winds that howl at hundreds of miles per hour, shearing against each other in great rolling eddies and currents that have been turning and churning since before any human eye existed to observe them. The atmosphere of Jupiter is not still. It is never still. It is a living canvas of perpetual motion, a tapestry being woven and unwoven and rewoven at every moment, and the colors in it shift over years and decades as the chemistry of the clouds changes. As storms rise and fall, as one band brightens while another darkens, and the whole vast face of the planet rearranges itself in slow, eternal cycles. And then there's the eye, the great red spot. Even the name has a kind of quiet gravity to it, a weight that settles in the chest when you say it aloud in the dark. It sits in Jupiter's southern hemisphere like something watching a storm, an anticyclone, a swirling vortex of wind and cloud that has been turning without pause for at least 300 50 years. 350 years. When this storm was first recorded by human observers, there were people still alive who had been born in the same century as Shakespeare. The storm was already old then, already ancient, already a permanent fixture in the face of the solar system's largest world, and it has not stopped since. It turns and turns and turns, counterclockwise, a slow and majestic rotation that takes about 6 days to complete one full cycle of the vortex's inner winds, and it is larger, this single storm. This one weather system on a planet with no solid surface, larger than the entire Earth, our whole world, with all its oceans and all its mountains and all its billions of lives and all the light from all its windows at night, could be set down inside the Great Red Spot, and it would not even reach the walls. What color is it exactly? That is a question scientists still wonder about, because the redness of the Great Red Spot is not fully understood. There are theories, beautiful and careful theories, about complex organic molecules and phosphine rising from deep within the atmosphere and being broken apart by ultraviolet light, about sulfur compounds and photochemical reactions at the tops of towering cloud decks. But the exact recipe of the storm's deep amber-red color remains one of Jupiter's quiet secrets. One of the things it has not yet told us. Perhaps one of the things it is in no hurry to share. And beneath all of this, beneath the storms and the bands and the spinning and the ancient red eye, Jupiter keeps company. It is not alone in its travels around the sun. It carries with it a vast retinue of moons, at least 95 known moons, a whole small solar system of worlds orbiting this one enormous planet, some of them tiny and irregular. Captured asteroids or wandering rocks that Jupiter pulled into its embrace long ago with that immense gravitational patience of its. Others larger and more ancient and more extraordinary than anything a sleeping mind might easily conjure. The 4 largest, the Galilean moons, were first observed by Galileo Galilei in the early 17th century, and that discovery alone was one of the most revolutionary moments in the history of human understanding, because here were 4 worlds clearly orbiting something other than the Earth. Proof written in light that the Earth was not the center of everything, that other centers existed, that the universe was larger and stranger and more various than any single point of view could contain. Io, a world of volcanoes so active and so dramatic that its surface is constantly being repainted in yellows and reds and whites from eruptions that shoot plumes of sulfur hundreds of miles into space. Ganymede, the largest moon in the entire solar system, larger even than the planet Mercury, a world with its own magnetic field and a surface of ancient ice. Callisto, pocked and ancient, its face a record of every impact the outer solar system has ever thrown at it. A world that has not changed geologically for billions of years. A quiet keeper of deep time. And then Europa. Europa deserves to be spoken of slowly, the way you speak of something that still fills you with wonder even after you have held the thought of it many times. It is one of the smoothest worlds in the solar system, its surface a vast plain of water ice so pure and so flat that from certain angles it looks almost like a painting of a frozen landscape, crisscrossed by long reddish-brown lines and ridges that scientists call lineae, cracks and fractures in the ice where the shell has shifted and moved and sometimes allowed material from below to seep upward and freeze again. And below, beneath that shell of ice, which may be anywhere from a few kilometers to tens of kilometers thick, depending on where you look. Beneath the ice there is an ocean, a vast, liquid, saltwater ocean, kept liquid not by the warmth of the sun, which barely reaches this far, but by the gravitational flexing of Europa's interior, by the tidal forces of mighty Jupiter pulling and squeezing the moon as it orbits, generating heat deep within the rock and keeping the ocean above that rock from ever fully freezing. This ocean is estimated to be deeper than any ocean on Earth, and it contains more liquid water than all of Earth's oceans combined. Does something live in that dark water beneath that distant ice? We do not know. We have not yet found a way to look. But the question is alive. It is one of the most alive and trembling questions in all of planetary science. And every time a probe passes near Europa, every time a new image returns to us of those fractured ice plains, the question hovers there in the silence between the data points, neither answered nor dismissed, just waiting patiently in the way that the most important questions always wait. Jupiter holds all of this. It holds the storms and the history and the ancient chemistry and the spinning and the moons and the perhaps alive ocean and the eye that has been watching the solar system for 3.5 centuries without once blinking. It holds all of it in that enormous, gaseous, magnificently unsolid embrace, anchoring the outer solar system with its gravity, deflecting comets and asteroids that might otherwise wander inward toward the rocky worlds where life has, at least once, found a way to exist and to look back outward at the stars. To lie still and think of Jupiter in the quiet before sleep is to do something the human animal has always needed to do, which is to feel small in the presence of something beautiful. Not frightened, not diminished. Just small in the way that is also a kind of freedom, the way standing beneath a great and spreading tree makes you feel small, or the way music can fill a room so completely that you stop feeling the edges of yourself and simply float inside the sound. Jupiter offers that kind of smallness, the kind that opens rather than closes, the kind that makes the chest feel wider rather than tighter, that makes the breath come slower and deeper and more grateful. It moves out there now, as it has for 4.5 billion years, this enormous quiet giant, its clouds rolling, its storm turning, its moons tracing their faithful arcs around it in the dark. And it asks nothing of us except occasionally to be looked at, to be wondered over, to be let in through the door of the imagination on a calm and sleepy night. And yet, for all its grandeur, for all its swirling bands of amber and cream and the ancient red eye of its never-ending storm, Jupiter is not alone in its majesty among the gas giants, for further still along the long, dark highway of the solar system, another world waits with rings so delicate and so breathtaking that even now, after centuries of observation, they still inspire the same soft wonder as the first time a human eye pressed itself to the glass of a telescope and looked upward into the dark. That world is Saturn, and if Jupiter is the king of the solar system, loud, magnetic, commanding, then Saturn is something quieter, something that belongs more to the realm of dreams than declaration. Saturn is the kind of beauty that does not announce itself. It simply exists, serene and impossible, hanging in the black like a painting someone placed there and forgot to explain. Even the light that reaches Saturn is different. By the time the sun's warmth has traveled the nearly 1.5 billion kilometers it takes to arrive at this pale golden giant, it has grown thin and soft, the way candlelight softens a room at the edges. And yet Saturn glows. Saturn shimmers. Saturn wears its rings the way the surface of a still lake wears the reflection of the moon, with a kind of effortless, unearned perfection that makes you stop mid-breath and simply stare. Let yourself stare now if you like. Let your eyes grow heavy and your breathing slow, and let the image of Saturn drift into your mind the way a memory drifts up sometimes just before sleep, unhurried, luminous, arriving without asking permission. There it is, a sphere of pale gold and soft amber, banded with the quietest of atmospheric currents, wrapped in a halo of rings so vast and so geometrically precise that they look less like something that happened by accident and more like something someone drew very carefully with a compass on the dark. Those rings, those extraordinary, impossible rings, they span up to 282,000 kilometers in diameter. That is a distance so large that if you laid it flat beside the Earth, you could fit more than 22 Earths side by side across their width. And yet, for all their breathtaking span, those rings are remarkably, almost unbelievably thin. In most places, they are less than 100 meters thick, less than the length of a city block, less than the height of a modest building. Imagine a sheet of paper stretched wide enough to wrap around a continent, and you begin to approach the extraordinary proportions of what Saturn wears around its middle. They are almost nothing, and they are almost everything, all at once. And what are they made of? Ice, mostly ice. Ice and rock, in fragments and particles ranging from grains smaller than a snowflake to chunks as large as a house, tumbling, glittering, endlessly orbiting. Each one following its own quiet path around the planet at its center. They are not solid, these rings. They are not a disk or a sheet in any continuous sense. They are a vast, slow conversation between millions and millions of individual pieces of matter, each one too small and too far to see individually, but together composing something so beautiful, it becomes its own kind of silence. When sunlight reaches those particles, that thin, traveled, patient sunlight that has spent more than an hour crossing the distance from the sun just to arrive here, it catches each piece of ice the way winter morning light catches frost on a window pane. Every particle becomes briefly its own small lamp. And because there are so many of them, and because they are spread across such an enormous and gossamer-thin plain, the effect is like watching snow fall in perfect silence across a world made of light. There is no sound out there, of course. There is never any sound in space. But if there were, the rings of Saturn might sound something like the softest possible music, the kind that plays at the very edge of hearing, the kind you are not sure you imagined or truly heard. We have known about these rings since the 1600s, when a Dutch astronomer named Christian Huygens first understood that the strange appendages Galileo had noticed decades earlier, those blurry, uncertain shapes that seemed to flank Saturn on either side, were not companion moons or atmospheric distortions, but a ring around a planet. The idea was so new, so structurally unfamiliar to human imagination, that it took a while for the word itself to settle correctly. A ring around a world. And now we know it is not just one ring, but many. A whole architecture of nested rings separated by gaps and divisions, each one named for the astronomers and mathematicians who spent their patient years trying to understand them. But the rings are only the beginning of what makes Saturn extraordinary. There is the planet itself to consider, and the planet, too, is full of gentle wonders. Saturn is the least dense planet in the entire solar system. It is a world made mostly of hydrogen and helium, light elements gathered into a sphere more than 9 times the diameter of Earth, and yet so diffuse, so loosely arranged inside itself, that if you could somehow find an ocean large enough to hold it, an ocean the size of a small solar system, perhaps Saturn would float. It would sit on the surface of that water like a vast, improbable ship, its rings spread around it in the waves, its moons circling it as seabirds circle a vessel that has lost its way, but has not yet lost its dignity. A planet that floats, a gas giant made, in the truest sense, of something closer to air than stone. And inside that soft body, something is happening. Saturn is warm. Not warm in the way a summer afternoon is warm, not warm in any way a living creature would welcome, but warm in the deep and ancient way of stars that did not quite become stars. Saturn emits roughly twice as much energy as it receives from the sun. It is generating its own heat from the inside through a process of slow gravitational contraction, the same kind of gentle compression that happens when a gas cloud collapses. The same process that lights the stars, only here occurring too slowly and too softly to ever ignite into anything like fire. Saturn is contracting almost imperceptibly, degree by degree, year by year, millennium by millennium. And in doing so, it is releasing warmth that has been stored inside it since the beginning of the solar system. It is, in a way, still in the process of becoming, still settling, still slowly finding its final shape across spans of time that make the whole of human history feel like a single quiet breath. Around this warm, floating, impossibly ringed world, a family of moons moves in its endless orbital dance. 146 known moons. 146 worlds in miniature, each one caught in Saturn's gravity, each one traveling its own circuit through the cold. Some are tiny, irregular shapes like potatoes or river-worn stones, captured long ago from the asteroid belt or from the outer reaches of the early solar system, held now in Saturn's embrace perhaps for the rest of time. Some are stranger than strangeness has a word for, Hyperion, tumbling erratically in a rotation so chaotic that scientists cannot predict which face will be pointing sunward from one orbit to the next. Iapetus, half brilliant white and half coal black, as if it were two different moons stitched together along a seam. Enceladus, small and brilliantly white, with geysers of water ice erupting from its southern pole, a frozen moon with a liquid ocean beneath its surface, exhaling into space. But the moon that holds the imagination longest, the moon that you might find yourself thinking about just before sleep, is Titan. Titan is large, larger than the planet Mercury, larger than any other moon in the solar system, save Jupiter's Ganymede. And Titan is remarkable in a way that is almost uncomfortable to contemplate calmly, because Titan has an atmosphere, a thick, dense, orange-brown atmosphere made primarily of nitrogen, the same nitrogen that makes up most of the air you're breathing right now, in whatever warm and quiet room you're resting in. You and Titan share something. Your lungs are full of what Titan's sky is made of. But Titan's atmosphere also contains methane. And on Titan, methane does something extraordinary. It behaves the way water behaves on Earth. It evaporates from the surface and rises into the atmosphere. It condenses into clouds. It falls as rain, and it collects in great still bodies on the surface, lakes and seas of liquid methane, dark and cold and calm, sitting beneath that orange haze, the way an alpine lake sits beneath morning fog. There are waves on those lakes, gentle and slow, because methane is less viscous than water and Titan's gravity is low and the winds are soft. Radar images from the Cassini spacecraft showed those shorelines in silhouette, the edges of liquid methane meeting solid water ice in a world nearly 1.5 billion kilometers from the sun, in temperatures so cold that rock would shatter like glass. And yet, there is weather there. There is a water cycle, or its methane equivalent. There are seasons on Titan, long and slow, because Saturn itself takes nearly 29.5 Earth years to complete one orbit around the Sun. Titan follows Saturn through that orbit, and so Titan's seasons are measured not in months but in years. Summers that last long enough for a child born into them to grow old before autumn arrives. The Cassini spacecraft spent 13 years in orbit around Saturn, and in that time, it changed our understanding of this system so profoundly that even the scientists who built it were not prepared for everything it found. It flew through the plumes of Enceladus and tasted them. It mapped the methane seas of Titan with radar. It watched the rings from inside and saw their structure in more detail than any telescope had ever allowed. It watched storms brew on Saturn's surface, hexagonal storms at the North Pole, a perfect geometric pattern that has no clear analog anywhere else in the solar system. A six-sided hurricane the size of 2 Earths, rotating slowly in the atmosphere of a world that floats. In September of 2017, after years of service and with its fuel nearly spent, the Cassini mission team flew the spacecraft deliberately into Saturn's atmosphere, where it burned and became, in its last moments, part of the planet it had spent so long observing. There is something in that ending that feels less like a conclusion and more like a homecoming. A spacecraft built of human thought and human hands, returning at last to the world it loved best, becoming part of the great warm interior, adding its atoms to the hydrogen and helium and everything else that turns slowly inside that pale golden sphere beneath those extraordinary improbable rings. The rings themselves are thought to be relatively young in cosmic terms, possibly only a few 100 million years old, formed perhaps from a moon that strayed too close and was torn apart by tidal forces, or from a collision in Saturn's outer system that scattered debris into orbit. They will not last forever. They are slowly spiraling inward, raining down onto Saturn's atmosphere in a process so gradual it would take hundreds of millions of years to complete. We are, it seems, living in a fortunate era, arriving just in time to see Saturn at its most adorned, in the brief window of cosmic history when those rings are at their most complete, their most spectacular, their most quietly breathtaking. There is something in that thought worth sitting with softly for a moment, that the solar system itself has timing, that some of its most beautiful arrangements are temporary, lasting only for a few 100 million years, which feels like forever from inside a human life, but is barely an afternoon from inside the life of a star. That we are here now with our telescopes and our spacecraft and our wondering eyes, precisely when the jewel is at its most jewel-like, precisely when the rings catch the light at their finest angle, precisely when Titan's methane lakes are still and full and the geysers of Enceladus are still erupting quietly into the cold. There is no reason to rush past any of this. Let your mind move slowly through this part of the solar system, the way light moves slowly this far from the sun, arriving late and gentle and already tired from its long journey, but arriving all the same, touching the ice of each ring particle, illuminating each moon briefly before the long orbital night returns. Feel how quiet it is out here. Feel how the distances between things have grown. Feel how each world you visit from here onward will be a little colder, a little darker, a little further from the warmth that began all of this. and feel how that is not frightening. How that is simply the nature of space, generous with its silences, patient with its distances, asking nothing of you except that you remain awake long enough to notice what is there. Saturn is there, floating, glowing with its own gentle heat, dressed in its thin, impossible rings, accompanied by its 146 moons, its largest moon dreaming of methane rain beneath orange skies, its smallest moons tumbling freely in the cold and dark, all of it real, all of it out there, continuing without us, continuing whether we look or not, continuing in perfect and unhurried silence while we rest here with our heads on our pillows and our breathing slow and our minds drifting through a solar system that is larger and stranger and more quietly beautiful than any dream we might have thought to construct for ourselves. Breathe in, breathe out. Saturn turns. The rings catch the far light and scatter it in long, cold, luminous ribbons across the dark. And as we linger in imagination near those translucent rings, watching their icy fragments catch the faraway sunlight in long, cold ribbons, we feel the temperature of the solar system dropping around us, growing more hushed, more distant, as we drift still further outward toward a world tilted so dramatically on its side that its seasons last for decades, and its moons tumble in strange patterns around an axis that, and as we linger in imagination near those translucent rings, watching their icy fragments catch the faraway sunlight in long, cold ribbons, we feel the temperature of the solar system dropping around us, growing more hushed, more distant, as we drift still further outward toward a world tilted so dramatically on its side that its seasons last for decades and its moons tumble in strange patterns around an axis that points not upward, not perpendicular to the great orbital plane like so many of its siblings, but sideways, nearly horizontal, aimed almost directly at the sun during certain long and extraordinary seasons, as though this world decided long ago to lie down and rest, and has been resting ever since. This is Uranus, and the story of how it came to lie this way is not a gentle one, though the world itself appears, from this quiet distance, impossibly serene. Early in the life of the solar system, when the planets were young and still gathering themselves from the swirling debris of a newborn star, the space between worlds was far less orderly than it is today. Objects moved on uncertain paths. Some of them were enormous, protoplanetary bodies carrying within them the mass of continents, of oceans not yet formed, of rocks still cooling from the fires of formation. And one of these ancient wanderers, something very large, something perhaps the size of the Earth itself, or perhaps larger, came sweeping through the outer reaches of that primordial solar system and struck Uranus with a force that rearranged everything, not destroyed it, not shattered it beyond recognition, but tilted it, the way you might tilt a spinning top with a careless hand, except that in this case the hand was a world, and the force behind it was astronomical, and the tilt it left behind was 98 degrees, almost exactly on its side, and that tilt has remained ever since, written permanently into the geometry of Uranus, encoded in the strange poetry of its orbit. When you imagine that collision now, from here, in the softness and quiet of wherever you are lying or sitting or resting your eyes, try not to think of it as violent, or at least try to hold both things at once. The violence of the event and the extraordinary stillness it eventually produced. Because the solar system has a way of absorbing catastrophe into calm. What begins in collision ends in orbit. What begins in chaos ends in a world drifting quietly in blue-green light, turning on its side, season after long season, each pole spending 40 years in sunlight and 40 years in darkness, patient and unhurried, like something that has made peace with its own strangeness. And strange it is, this world. Its axial tilt of 98 degrees means that the poles receive more direct sunlight over the course of a Uranian year than the equator does, a reversal of the pattern we know from Earth, where the tropics bask and the poles shiver. On Uranus, the poles are the places of long, slow warmth, and the equator passes through the middle ground between them, never quite centered in the light. Its moons orbit not in the flat plane of the solar system, but around that tilted equator, as though they too accepted the aftermath of that ancient collision and arranged themselves accordingly. Loyal to the world's new orientation, orbiting in paths that from certain angles look almost vertical against the backdrop of the stars. And the color. Oh, the color of Uranus is something worth pausing over, worth letting settle into your imagination like paint dropped into still water. It is blue-green, a shade that has no perfect name, something between the color of a shallow tropical sea and the color of old glass, luminous and cool and faintly melancholy. That color comes from methane, the same molecule that on Earth you might associate with marshy ground or natural gas. But here, high in the Uranian atmosphere, it performs a different kind of chemistry. Sunlight falls onto the planet, carrying within it the full spectrum from red to violet, and as that light passes through the methane-rich upper layers, the red wavelengths are absorbed, pulled out of the picture, drunk up by the molecular structure of the gas. And what remains, what scatters back out into space and eventually finds its way to our eyes and our telescopes and our imagination, is that blue-green glow. The planet is, in a sense, showing us only what it cannot absorb. It is defined by what it lets go. Beneath that atmosphere, the nature of Uranus becomes something harder to picture because it is neither the rocky solidity of the inner worlds nor the swirling gas of Jupiter and Saturn. It is something else, something in between, something the scientists have given the name ice giant, though the word ice here does not mean what it means on a winter morning or inside a glass of water. Deep inside Uranus, under enormous pressure, under layers of hydrogen and helium that make up the outer atmosphere, there lies a vast mantle of what we call ices, water, ammonia, methane. But these substances exist under conditions so extreme that they are not quite solid, not quite liquid, not quite anything we have a comfortable word for. They are dense, pressurized, hot in a way that contradicts what we expect from ice, and they make up the great bulk of the planet's mass. This is the ice of deep compression and immense gravity, the ice of a world that formed in the cold outer reaches of the solar system and gathered to itself the lighter, more volatile molecules that the inner planets never had a chance to hold on to. It is a world of deep, quiet strangeness, and from this distance, with the sun now reduced to a point of light far behind us, barely warmer in appearance than the surrounding stars, Uranus drifts in its own blue-green serenity, tilted and patient, keeping its secrets beneath that luminous skin. And then, further still, further even than that, deeper into the quiet, Neptune. If Uranus is the world that lies down, Neptune is the world that whispers, and the whispers it sends are the fastest winds in the solar system. This seems almost contradictory, doesn't it? That in a place so remote, so far from the sun's warmth and energy, where the light is so faint that a single day here receives about 900 times less solar radiation than a day on Earth. There should be storms and winds of such ferocity that gusts have been measured at over 2,100 kilometers per hour. Winds faster than anything that has ever moved across the surface of our own world, faster than most of what we would call extreme on Jupiter or Saturn, roaring through the deep blue atmosphere of a planet that receives almost nothing from the sun to drive them. How? This is one of the beautiful mysteries of Neptune, a question that scientists have turned over many times and still hold with a kind of reverent uncertainty. The sun, so diminished at this distance, cannot be doing all the work. Neptune must have its own internal heat source, warmth rising from within, from the slow cooling of the planet's interior, from the compression of its deep icy mantle, a kind of geological memory of its own formation, radiating outward over billions of years, and that internal heat, meeting the cold of the outer atmosphere, creates gradients, differences in temperature and pressure that drive the winds, that stir the atmosphere into those extraordinary velocities that produce the great dark storms that Voyager 2 glimpsed when it flew past in 1989, including one enormous storm called the Great Dark Spot, a swirling darkness in the southern hemisphere that has since vanished and been replaced by others. The atmosphere of Neptune, a restless, shifting, churning thing that never quite settles. And yet from here, from wherever you are resting, Neptune appears as a deep and tranquil blue, a blue even richer and more vivid than Uranus. A blue like the deep ocean seen from above, at the clearest possible moment, like the color of distance made visible. It wears this color for the same reason Uranus does. The methane in its atmosphere absorbing the red wavelengths, leaving behind that extraordinary blue, but Neptune's blue is somehow deeper, more saturated, as though the planet has more fully committed to the color, as though it has nothing left to prove to the warmer, brighter worlds behind it. Like Uranus, Neptune is an ice giant, its bulk composed of that same strange mantle of pressurized water and ammonia and methane beneath a hydrogen atmosphere, the same family of molecules, the same inner architecture of compressed volatiles, the same category of world that formed in the cold territories of the outer solar system, where the lighter ices could accumulate and persist. These two worlds are siblings in composition, twins in their essential nature, even as they differ in their personalities, one tilted and quiet, one upright and wind-torn. And Neptune has a moon. Neptune has several moons, in fact, but one of them demands our attention with a particular kind of quiet insistence, and its name is Triton. Triton is large, larger than Pluto, large enough that it holds a thin atmosphere of nitrogen, large enough that its surface is a frozen landscape of nitrogen ice, and strange formations the scientists have called cantaloupe terrain for its irregular, dimpled appearance, large enough to make itself felt in the gravitational life of the Neptune system. But what makes Triton remarkable? What gives it its particular strangeness is the direction it moves. Every large moon in the solar system orbits its planet in the same direction that the planet rotates. This is the expected pattern, the natural outcome of formation from a single spinning disk of material, the way a family of objects born from the same cloud of gas and dust will tend to move in harmony, all rotating the same way, all orbiting the same way, because they all inherited their momentum from the same source. But Triton does not do this. Triton orbits Neptune backwards, moving in the direction opposite to Neptune's own rotation, a retrograde orbit that is the clearest possible signal that Triton was not born alongside Neptune. did not form from the same disk, did not inherit its motion from the same cloud of material. Triton came from somewhere else. Scientists believe that Triton was once a free body in the outer solar system, a resident of the Kuiper Belt, that vast ring of icy objects beyond Neptune's orbit, drifting in its own independent path around the Sun, until Neptune's gravity reached out and captured it, pulling it in, bending its path into an orbit, claiming it as a moon. The capture must have been a violent and chaotic event. Orbital captures on this scale require energy to be dissipated somehow, often through complex gravitational interactions, often at great cost to any other moons that might have been orbiting Neptune at the time. But the result, the settled aftermath of that ancient gravitational drama, is Triton in its retrograde orbit, a captured wanderer going the wrong way around a deep blue world at the edge of the known solar system. And Triton's future is already written in its orbital mechanics. A retrograde orbit is unstable over geological time. The tidal forces between Triton and Neptune are slowly, imperceptibly, century by century, drawing Triton closer. Not in any human lifetime, not in any time scale you would call soon, but in about 3.5 billion years. Triton will spiral close enough to Neptune that it will cross what is called the Roche limit, the point at which tidal forces will overcome the moon's own self-gravity and Triton will be torn apart. Its materials scattered into a ring around Neptune, a new ring system born from the destruction of a captured wanderer. Neptune will have, in the very long fullness of time, consumed the moon. It once seized from the Kuiper Belt, and what was a world will become a halo of glittering ice. But that is so far from now. For now, Triton orbits in its backward circuit, nitrogen geysers occasionally erupting from its southern hemisphere, sending plumes of dark material into its thin atmosphere. The only known geologically active body in the outer solar system after Io and Enceladus, a frozen world with something still alive in it, however faint, however cold. There is something about this pair, Uranus and Neptune, the ice giants at the edge, that carries a particular emotional quality, something that feels like the last page of a letter. The last note of a melody played very softly, the last breath before sleep. They are so far away, these worlds. So far that when Voyager 2, the only spacecraft ever to visit either of them, flew past Neptune in 1989 after a 12-year journey, the signals it sent back traveled at the speed of light and still took 4 hours to arrive. 4 hours for light to cross that distance. 4 hours of silence before the news arrived. And now Voyager 2 has left the solar system entirely, sailing outward into interstellar space, and no other spacecraft has visited these worlds since, and they continue their long orbits in the dark. Unhurried and unremarked, blue-green and blue-deep, composed of compressed ancient ices, home to winds and captured moons and the memory of ancient collisions. When you think of the solar system, you might first think of the sun, warm and enormous, or the blue and white marble of Earth seen from space, or the rings of Saturn catching the light like a jeweler's dream. But these outermost worlds, these quiet ice giants at the edge, are part of the same story, woven from the same original cloud of gas and dust, shaped by the same gravity and the same violence and the same patient accumulation of time. They are not afterthoughts. They are not merely distant and cold. They are the long, slow exhalation of a solar system that breathed its first hot breath 5 billion years ago and has been breathing out ever since, its atmosphere expanding, its warmth diffusing, its edges growing quieter and more remote with each passing billion years. And sitting out here in the imagination, in the deep cold and the blue-green dark, watching Neptune's winds howl invisibly beneath that tranquil surface, and Triton trace its backwards orbit like a traveler who has forgotten which direction home is. There is a quality of stillness that is unlike any stillness found in the inner solar system. It is the stillness of great distance, the stillness of enormous cold, the stillness of a place where the sun is merely a very bright star, and the darkness between objects is not absence but presence. A presence made of space and time, and the slow mathematics of gravity doing its patient work across billions of kilometers, and beyond even Neptune's deep blue winds and Triton's backwards frozen orbit. The solar system does not simply end. It dissolves instead into a vast and ghostly halo of icy wanderers. A place so far from the sun that its light arrives there only as a distant star among stars, a region known as the Kuiper Belt, and beyond it the Oort cloud, where comets sleep in the cold for millions of years before something stirs them and they begin their long, slow fall back toward the warmth, carrying within their ancient ice the very same molecules from which everything began. The water now pooling in your cells, the carbon braided through your bones, the nitrogen threading quietly through each breath you take. These same elements drifted through the cold dark of the early solar system 4.5 billion years ago, locked inside the ice of bodies that would one day become comets, waiting with extraordinary patience for a journey they could not yet imagine. It is a thought worth sitting with for a moment, in whatever warm and sheltered place you find yourself tonight. The comets did not know they were carrying anything precious. They did not know they were carrying anything at all. They simply drifted, slowly, in that unimaginable cold, held loosely in the outermost gravitational embrace of a young sun still learning how to shine. And yet inside them, like letters sealed and forgotten in a drawer, were the molecular ingredients of oceans, of atmospheres, of life. They carried organic molecules, complex chains of carbon and hydrogen and oxygen, assembled in the nebular cloud long before any planet had finished forming. They carried water ice, ancient and pure, crystallized at temperatures that make the coldest winter night on Earth feel almost tropical. They carried dust, silicate grains, metallic flecks, tiny dark particles that had traveled from dying stars before this solar system was even a suggestion. A whisper of possibility in the arm of a spiral galaxy. And so when we look up and see a comet crossing the sky, trailing its luminous veil of sublimated ice and dust, glowing softly against the black, we are not simply watching a rock fall toward the sun. We are watching a time capsule open. We are watching 4.6 billion years of waiting come quietly to a close, at least for that one small wanderer, that one ancient messenger making its long, slow fall back toward warmth and light, carrying its cargo of beginnings to a solar system that has already used them, already built oceans and forests and soft mammalian creatures who lie awake some nights and wonder where they came from. The Oort cloud itself is something close to myth in the best possible sense of that word. We have never seen it directly. No telescope has resolved its members into individual points of light. No spacecraft has passed through its outermost reaches and sent back photographs. We infer its existence from the comets that arrive in our inner solar system on long, eccentric orbits coming from all directions, from above and below the plane of the planets, from angles that could only be explained by a source wrapped around the entire solar system like a shell, a halo, a cocoon of ancient ice. Astronomers estimate it extends from perhaps 2,000 astronomical units from the Sun, already a distance so vast it dissolves ordinary comprehension, out to perhaps 100,000 astronomical units, a sphere of frozen bodies marking the furthest edge of the Sun's gravitational reach, the last territory where our star can still whisper its influence and be heard. 100,000 astronomical units. Let that drift through you like something half-dreamed. A single astronomical unit is the distance from the Earth to the Sun, roughly 150 million kilometers, a gap that light crosses in about 8 minutes. The outer edge of the Oort cloud sits 100,000 times farther than that. Light from our own Sun. That familiar warm presence that rose this morning and painted the sky whatever color your particular corner of the world receives, takes more than a year and a half to reach the Oort cloud's outermost boundary. Out there, the Sun is not a sun in any meaningful visual sense. It is a star. A bright one, certainly the brightest in the sky, but a star nonetheless. A point of light no larger than the other points of light surrounding it, indistinguishable to any eyes that might, hypothetically be drifting in that cold and patient darkness. And yet, even there, even at the very edge of everything the Sun has claimed as its own, things happen. Something perturbs the orbit of a sleeping comet. Perhaps the gentle gravitational nudge of a passing star, perhaps a subtle tidal pull from the galaxy itself. Perhaps nothing more dramatic than the long, slow accumulation of tiny influences over millions of years, and it begins to move. Not quickly, almost imperceptibly at first. A drift in a new direction, a gradual steepening of its path, a slow surrender to the Sun's distant call. For perhaps 1,000,000 years it falls inward through the dark, crossing the distances between the stars and the planets at a pace that makes geological time seem hasty. Then, eventually, it crosses the threshold of the inner solar system, and the Sun's radiation reaches it with enough warmth to begin touching the ice, and the comet wakes. And it breathes out its luminous tail, and somewhere on a small blue planet, third from that star, a person lying in a field on a clear night looks up and sees something moving slowly, beautifully, impossibly through the stars, and does not know that they are looking at the same molecules that once made their world. There is a boundary closer than the Oort cloud that carries its own quiet significance. The heliosphere, that enormous invisible bubble inflated by the solar wind, by the continuous stream of charged particles flowing outward from the Sun in all directions, represents something more than a geometric curiosity. It is a shield. As the solar wind pours outward, it pushes back against the interstellar medium, against the radiation and cosmic rays that flow between the stars, and it creates a region of relative shelter. A protected pocket of space within which the planets and their atmospheres and their passengers can exist with somewhat less exposure to the harsher energies of the galaxy beyond. The heliosphere does not make the solar system safe in any absolute sense, and cosmic radiation still penetrates in significant amounts, but without it the environment would be measurably more hostile. And the story of life on Earth might have read quite differently, or might not have been written at all. We know something about what lies beyond the heliosphere because we have sent something there. In 1977, a spacecraft called Voyager 1 was launched from Earth on a trajectory that would take it past Jupiter and Saturn and then outward, always outward, into the deepening dark. It carried a golden record, a disk encoded with sounds and images from Earth, greetings in dozens of languages, music, the sound of rain, the sound of surf, the sound of a mother's first words to a newborn child, addressed to whoever or whatever might someday find it drifting among the stars. In 2012, Voyager 1 crossed the heliopause, the outer boundary of the heliosphere, and entered interstellar space, becoming the first human-made object to leave the solar system's protective bubble and move through the space between the stars. It is now more than 23 billion kilometers from Earth, a distance so large that the radio signals it sends back, traveling at the speed of light, take more than 21 hours to reach us. And yet it is still there, still transmitting, its instruments still gathering data about the environment between the stars, its golden record still sealed against the cold, carrying its message of a small blue world into the dark. 23 billion kilometers, and still nowhere near the Oort cloud, still nowhere near the true edge of anything. The scale of this place we live in is not something the human mind can truly hold. It can only be approached, circled, touched lightly at the edges before it slips away again into incomprehensibility. And perhaps that is as it should be. Perhaps the appropriate response to the scale of the universe is not comprehension, but something softer, something closer to awe and acceptance, and the quiet setting down of the need to understand everything all at once. Our solar system itself is not standing still while all of this drifts around it. The sun, carrying all of its planets and moons and asteroids and comets and the far dreaming reaches of the Oort cloud with it, moves through the Milky Way galaxy in a vast, slow, nearly circular orbit around the galactic center. This orbit takes somewhere between 225 and 250 million years to complete, a span of time so deep it has its own name, the cosmic year or galactic year, a unit of time beside which human history vanishes like a breath in cold air. When the solar system last occupied this same position in the galaxy, the first dinosaurs were only just beginning to appear on Earth. 2 cosmic years ago, there were no complex multicellular animals here at all. The galaxy turns, the solar system rides within it like a boat on a slow, deep river, and the stars that surround us now are not the stars that surrounded us then, because everything is moving. Everything has always been moving, and all positions are temporary. All configurations are fleeting, and yet somehow in the midst of all that, motion there has been just enough stability for water to pool in the low places of a rocky world, for molecules to meet and link and learn to copy themselves, for life to arise and persist and eventually look up. There is something extraordinarily calming in this, if you let it settle into you rather than holding it at arm's length. Not the terror of scale, not the vertigo of deep time, but the comfort of belonging to something so much larger than any individual worry or urgency or tightly held concern. You are made of the same ancient ice as the comets sleeping in the Oort cloud. You carry in your body the evidence of stellar nurseries and supernova explosions and the long, slow chemistry of the early solar system. The oxygen in your lungs was forged in the heart of a star that died before this solar system was born. The iron in your blood remembers the violence of stellar collapse. The water moving through you has been rain and ocean and glacier and vapor and the interior of a comet long before it was ever you. And tonight, wherever you are riding on a small and beautiful world that is itself riding a middle orbit around an ordinary star that is itself sweeping through one arm of a spiral galaxy at many kilometers per second, completing a vast circuit that has taken hundreds of millions of years for every single lap. While beyond the outermost planets, The comets sleep in their cold halo, holding their ancient molecules with the patience of objects that do not know they are waiting. And somewhere in the dark between the stars, a golden record drifts on, carrying the sound of rain. There is nowhere else you need to be. There is nothing you have forgotten to do. The galaxy turns as it has always turned, unhurried and indifferent to urgency, and you are a small and temporary and extraordinarily unlikely arrangement of atoms that somehow learned to breathe and think and lie still in the dark and feel the weight of the universe settling gently, like snow, like the first silence after a long noise finally stops, like the universe itself exhaling and finding, in that exhalation, something it did not expect, something quiet and warm and briefly, softly here. And so our gentle journey through the solar system floats quietly to rest, each planet settling back into its slow, celestial dance. If you are still softly awake, another chapter waits patiently whenever you're ready. But for now, let the stars carry you. Let Saturn's rings be your lullaby. Let Jupiter's gentle storms rock you like ocean waves. Sleep beautifully, dear one. Good night.